Hello, today we have a practical lesson on graphical representation of motion. The figure shows a graph of motion of some body, and we see how this body moves, we see what positions it passes through, in what time this position changes. And let us answer the following questions. First question. Without making calculations, we will have to compare the velocity of motion of the body at these three sites. Further, it will be necessary to understand what speed we are talking about. We can talk about the traveling speed and also about the speed of displacement. That is, we must compare these three speeds with each other. That's the first task. The second task. We will need to determine the average speed of travel over a period of 5 seconds. Again, we're going to talk about two speeds. This is the average traveling speed and the average traveling speed. Let's start with the first task. We need to compare the traveling speeds at three sections A, B, and C and put certain signs between these three speeds. Let's write them out in this form for now. When we take the speed of travel into account, our main focus is on the distance covered during the journey. It is also important to analyze the angle at which the graph inclines relative to the time axis. It is evident that graph A has an inclination angle of alpha. By comparing this angle to the inclination angle of graph B, we can gain further insight into the data. Based on the given information, it is evident that the angle in question will be greater. As a result, we can assert that the velocity on plot B will exceed the velocity on plot A, thereby indicating a direction. Moreover, by considering the gamma angle formed by graph C with the time axis, it becomes apparent that angle B is the largest among the three angles, establishing that the velocity of B will be the greatest. Therefore, we can represent this information in the provided format. Now, in order to determine the velocity of the displacement, we can look at this angle of the graph, or we can determine it right here in this triangle as a cross triangle. They're going to be equal. And we can see that this angle lies already under the time axis. This indicates that the tangent of this angle will have a negative sign. That means that the velocity of displacement in this case will also be negative. So we can write that the minus velocity of displacement on segment A has a minus sign. Now, the velocity at segment B will have a plus sign. Because here we already have a positive tangent and the angle to the time axis is above this direction. And in the same way we can see at segment C. The velocity of displacement will also be negative. By magnitude we have already determined how modulo they relate to each other, and by signs we also already see where which sign of velocity will be present. We can also compare them with each other. Here the only thing is that if we take into account the sign of the velocity, it is clear that the velocity, which has a negative sign but larger in modulus, it will be in the end less. So it turns out that the velocity of point A in this case will be less. The velocity of point C will be greater than the velocity of point A, and the velocity of point B will be the greatest. We can write it down like this. That is, the velocity of point C will be greater than the velocity of point C and greater than the velocity of point A. Therefore, by utilizing this graph, we can ascertain the speed at which travel occurs as well as the speed at which displacement occurs. In order to determine the average velocity of travel, then for this purpose we must determine what path the body has traveled during all these three sections. In other words, to calculate the total of all the displacements made modulo and divided by the corresponding time intervals. Let us see what dx1 is. We see that here the body has moved from coordinate 3 to coordinate I, i.e. the displacement is 2 meters. Then at plot B, from coordinate 2, the body has moved to coordinate 3, i.e. 2 meters. At plot C from coordinate 3 to coordinate 2, the body has moved, i.e. the displacement is 1 meter. And divided by the total time taken for all these displacements, we see that the total given time is 5 seconds. And we end up with an answer of 1 meter per second. That would be the average traveling speed. Now, if we want to find the average travel speed, we'll write it like this. Here we see that the initial position of the body is 3 meters, the final position is 2 meters, and the displacement of the body will be equal to the difference between the final position and the initial position of this body, and the time of this displacement is still 5 seconds. And then we get the answer -1 divided by 5, or -0.2 meters per second. So now we show you that also the average ground speed and average travel speed are at different speeds. So with the help of the graph, we can also see the difference between them clearly. This concludes our practical lesson. Goodbye.